Welcome to EDU World Space.
All right, so let's take a look at containers that are of equal volume, and they contain two gases, nitrogen and helium. And in addition to being an equal volume, they are all at the same temperature, so an equal temperature. And so let's figure out some factors about each of these substances and kind of like rank the boxes 1, 2, and 3. So if we wanted to know about the total pressure of the system, well, total pressure, if the volumes are the same, that's going to be proportional. So that little alpha means proportional to the number of particles in the system. So more particles, more pressure. And so let's take a look at the number of particles. Box 1 has N2 counts as 1 particle. So we have 1, 2, 3, 4, 5, 6, 7 particles. We have 1, 2, 3, 4 particles. 1, 2, 3, 4, 5, 6, 7 particles. So in terms of total pressure, 1 and 3 are going to be of the same pressure, and 2 is going to be the least pressure. So we're going to wind up having the fact that 1 is the same as 3, and both of those are greater than 2. Now, when we take a look at partial pressure of helium, again, it's going to be proportional to the number of particles, but this time, since we're only talking about helium, it's going to be of helium. So the greater the amount of helium, the greater the pressure of helium. So helium is represented by the green dots. We have 5 in number 1, 3 in number 2, and 2 in number 3. So the pressure is going to be highest in 1, then 2, then 3. So 1 is greater than 2, and 2 is greater than 3. Now, when we're talking about density, remember the equation for density. Mass over volume. So when we're talking about the density here, we have all the same volume. V is the same. So since V is constant, M is our issue, right? So the greater the mass, the greater the density. So let's find the one with the smallest and the biggest mass. All right, so mass of nitrogen is 28, helium is 4. So when we're taking a look at these, 28, my goodness, 28 plus 28 plus 28 plus 28, 28. The one with all the nitrogens is going to wind up being the heaviest. And then 28 plus 28 is 56. And we have 5 times 4 is 20, right? That's going to be the second one. And then this one with the fewest nitrogen and the fewest number of particles overall will have the lowest mass. So 3 is going to have the highest density, 1 the next, 2 the least. 3 is greater than 1, which is greater than 2. And finally, average kinetic energy. Now that's the definition for a term, for a word. That means the average kinetic energy is temperature. So what does that mean? Well, all of these 3 are at the same temperature. Same temperature equals same kinetic energy. So they're all at the same temperature, same kinetic energy. So for this one, 1 is the same as 2, which is the same as 3.